Okay, here are a few exercises from 2.4. I'm not going to do these completely, but I want to give you some idea about how to think about these exercises. Let's start with 3b. Okay, so we'll copy that here. Sorry. Actually, I meant 3d, so I'm going to change that to 3d. There are several limits like this, and you can do this in the easy way or a hard way, but I think it's better to do it the easy way. So let's see what the easy way is. All right. Now what you want to do is express this in terms of limits that you know. Okay. Now in fact, all of these you can see have some relation to sine h over h. And we know that the limit of sine h over h is 1. So I'm just going to write that this way informally. Sine h over h goes to 1. Okay. I could write limits and so on, but let's just do this informally. Now consider this sine h over 5h. Can I write this in such a way that it relates to this? Well, I can take out the 1/5. And then I have sine h over h. All right. Now if you write it that way, it should be pretty clear what the result goes to. Because 1/5 doesn't change, and this one goes to 1. So I think you can figure out the answer there. All right. So that's kind of the way you should think about it. Break this up into things that you know. Right here also you can break this up into things that you know, and then take limits. You don't really want a 0 on the bottom. You want your zeros on the top, but you can make this work out. I mean, you don't want 0 over 0 limit. You want to get isolate a sine h over h or something involving sine h over h, and then multiply by something else that you know. All right. So that's kind of the approach here. 10a is kind of similar. Let's look at that one. That's kind of interesting. 10a is here. Now he does indicate something like this in the chapter. I do recommend you look back at the chapter at examples, because sometimes those examples really can help you. Let's look at a here. If I look at a, all right, I have 1 minus cos h over h squared. All right. Now, I know that 1 minus cos h goes to 0. Now, that doesn't really help me, because I have 0 over 0, so 1 minus cos h over h squared. That gives me 0 over 0. That doesn't help me. I don't know what that limit is. That could be anything. All right. So I want to do something a little bit better. So let's do something like this. And he does kind of indicate this trick in the chapter. I'll take over h squared. Let me multiply top and bottom by 1 plus cos h. Okay. So that's top and bottom by the same thing. Okay. All right. And that gives me 1 minus cos h times 1 plus cos h is 1 minus cos squared h. Right. And then here at the bottom I have h squared. And then I have 1 plus cos h. Now this numerator should look familiar. So I can isolate this into two parts. Okay. This here. Times 1 over 1 plus cos h. All right. Now, what does this one go to? Well, if you convert this numerator to what you know it is, then this is the square of the limit that you know. What does 1 over 1 plus cos h go to? Well, when h goes to 0, cos h goes to 1. So this second term is 1/2. So the limit is whatever this limit is times 1/2. All right? So that's kind of the reasoning that you can use for this one. All right? It's good to not just get the answer, but get the answer and think about what you're doing. All right? Let's look at 20b. And this is a very important example. It talks about the power, it shows the power of substitution. Okay. Let's look at this one. 20b. All right. I may say a little thing about 20a, but let's focus on 20b. All right. Let's find the derivative of sine of x plus 1 in two ways. And here he expands it for you. This is angle addition. Now when you compute the derivative, it's just the sum of the two derivatives. So that's an easy way to do it. Let's look at the next one also. Here it says divide delta y sine of x plus 1 plus delta x minus sine of x plus 1 divide by delta x. And then he says write capital X instead of x plus 1. So let's do that. Okay? So we have sine of x plus 1 plus delta x minus sine of x plus 1 divided by delta x. And then he lets capital X equal x plus 1. So he's getting sine of capital X plus delta x minus sine capital X over delta x. Now when delta x goes to 0, what does this become? Well, think about this. I could put anything in here. Before I used little x, if I have a little x there, then I know what the answer is. That's the derivative of sine with respect to little x. Now I have a capital X here. It's the same thing. It's the derivative of sine with respect to capital X. Okay. So that's just equal to derivative of sine, you should know, is cosine, right? But I substitute back in my capital X and I get cosine of x plus 1. Okay? So this shows the power of substitution in calculus. Right? I can do this and the limit still works, the derivative still works. That should be a total derivative, not a partial. All right? So substitution is always a very powerful method. All right, let's do one more here. Let's look at two more, 22. All right, 22. So you see these, although I assigned a lot of problems, you can see that these go fairly quickly. But you do need to know what you're doing. Okay, so here we see here. Okay, all right. All right, so here he's got this problem here. All right, so this one I just want to point out how he got that numerator there. Okay, sometimes you can break things up in more than one way. Here it says for y equals sine of 2x, the ratio delta y over h is this. My delta y is I replace the x with x plus h, and then I subtract the original. So here I've replaced the x with x plus h, and here I have the original, and then I divide by h. This is my usual derivative quotient. Now how did he get this? All right, you might wonder how to break this up. Well, I could use double angle formula here, or I could use something else. Now, if I use double angle formula, you can anticipate that I'm going to have a sine of x plus h and a cosine of x plus h. Now, there's no sine of x plus h or cosine of x plus h over here, so that's not helpful. So instead of writing sine of x plus h, cosine of x plus h, think a little bit, and you can consider this. That's the same thing as sine of 2x plus 2h. And then if you use angle addition formula, it turns out that you get directly to here. Okay, so there's more than one way to look at things. Take a look before you expand to see what is the best way to expand. Okay, so that's all I'm going to say about that. I think from there on it's pretty close, pretty familiar. Now let's look at this one here. Let's consider this one. What's the limit of cosine of 2h minus 1 over h? Okay, what does that go to? Okay, well, actually that one I know what it goes to. But let's consider, I'm going to change this problem a little bit. Suppose we had this limit here. So this is another problem, so let me this just suggested it to me just now, but I think it's something you might want to see. Cosine of 2h minus 1 over h squared. When h goes to 0, what is that? Okay, now here I have my 2h here. Okay, now I could, if I do something like this, I can write this as cosine of 2h minus 1 over, now see I have a 2h here, let me get this a 2h here also. So this is 2h squared divided by 4, right? So that's equal to 4 times cosine of 2h minus 1 over 2h squared. Okay? And here I want when h goes to 0. All right, now I can replace this 2h with something else. Maybe I'll replace it with capital H. Then I get 4 times cosine of h minus 1 over h squared. Now when little h goes to 0, capital H also goes to 0. Okay? All right, now this was the limit that we had up here. This is the same limit we had up here. Right? So whatever limit I get here, I can substitute that answer in. So the answer here is going to be 1/4, or it's going to be 4 times whatever answer I got for the previous. All right? So you can use substitution in a very efficient way to solve some of these problems. All right? Let's look at 22. That's the last one I'm going to do. That's right here. Oh, that is 22. All right. Let's look at 24. It's the one I was going to do. All right. Now here also, it's good to, you can do this the long way, or you can kind of do it the short way. All right. Here we have a sine plus a cosine. How do you deal with that? Well, it turns out you want to use angle addition. If you look at this, this almost looks like a angle addition formula. Here I have square root of 3. Square root of 3 is familiar. That's very closely related to the sine and cosine of pi over 3. Okay, so in fact I could, if I divide this by 2, I can write this as y equals 2 times 1/2 sine x plus square root of 3 over 2 sine x. Cosine x, sorry. Now think about this. What is 1/2? Well, 1/2 is the cosine of pi over 3. And then I have sine x. And then here I have, this is the sine of pi over 3. All right? So if we look at that, this is just the angle addition formula. So this is equal to 2 times sine of x plus pi over 3. All right? Very simple. Okay? So we can find the maximum value. You can see right away the maximum value of y is going to be 2. And the maximum value will take place when x equals what? Well, sine is, we want this here to be pi over 2. So we can say x equals pi over 6. All right? So we get the answer very quickly that way. All right. So it's actually pi over 6 plus 2k pi, if you want to be want to be complete about it. All right. And the slope at that point, we know the slope at any maximum is 0. All right. So there's some problems there. Hopefully that will stimulate you a little bit.